Okay, happy Friday, everybody. Everybody had exciting times with assignment 1. It was like, did anybody have like adrenaline rushes and stuff submitting it? Like a massive adrenaline rush? Like, yeah! This is awesome. Bob is going to be so amazed by this submission. It's going to be like shocking revelations. Anybody have questions about assignment 1? I guess not.
A decision tree counts.
A decision tree. Maybe, I'd have to see it. It might. I would like to see it, but if it's a graph, the graph generally would be fine. Yeah, it should be okay. So I'm going to conduct a psychic exercise to start today. I know one of the questions you have that you're all wondering, but you're too afraid to ask for no real reason other than what exists inside your imagination. And that is, when will I have them assessed? Right? I am going to try my best to have them assessed within 2 weeks. I'm going to try. I don't know exactly the answer, but that's what I'm going to try. Yeah. I know you're all wondering that. And you're all wondering about assignment 2. What is assignment 2 going to be? And now we're going to find out. Probably you already noticed it on Blackboard. Assignment 2 is there, waiting. So let's talk about assignment 2, volume visualization, volume data conversion, and discovery. Sounds like fun, doesn't it? It is 20% of the module, so this module has more weight on the coursework than most modules. Has everybody noticed that? So it's 50-50 rather than 20-80 or 30-70. It looks like we recommend you allocate 20 to 25 hours for it, and the deadline is the 23rd of April. And it makes sense, I think it makes sense to stick with the 11 a.m. time because you have a printout, you have a printed color report again. So you want to submit that when the university is open and when the student secretary is there, when the whole university is running, so to speak. You don't want to try to submit a printed version of your report at midnight or something. That's just not possible. So you are given a selection of 3 volume data sets. 2 of the 3 are unknown and mysterious. Your job is to explore, hypothesize, and discover what phenomena the data sets depict through the use of volume rendering. Rather than producing a volume renderer from scratch, you are to use an existing volume renderer. And then there's a list there of different possibilities. You're not restricted to the above software. You may use any volume rendering software. There are links to other open source volume renderers on the module webpage. You can also Google others. So the tools that are listed above are advanced state-of-the-art volume rendering tools freely available for educational and research purposes. They are open source volume rendering libraries which enable interactive visualization of volumetric data sets with high flexibility, and so on, right? Data format conversion. So this is one of the difficult challenges with assignment 2. Since the field of data visualization has not yet evolved to a point of using universal data format standards, the format of the data you have been given will have to be converted to a format that your chosen programs can read. The code you write to convert the data follows Bob's concise coding conventions, of which there's a copy online. The input data format for each tool is described on each tool's respective web pages. So every tool, as in, it's similar to assignment 1, This time it's more complicated. Getting the data in the correct format for use with a tool. That is a big technical challenge in this assignment. The mystery data sets can be downloaded from the usual URL. Currently, there are two phenomena to discover. One is called Sally. Sally is an analytical data set. The other is called Betty. She's a more traditional simulated data set on a regular grid. However, before you start working on unraveling the mystery data sets, start off with rendering a known data set. We recommend you render a known data set supplied by one of the renderers on the list above. For example, with Voreen, there is a standard walnut data set, and there can be downloaded. Right? So you would, that's part of the assignment, just to show pictures of a data set that you know the format of, you know the format is fine, it works, and just to make sure the tool that you're using works. Any sample data set provided by a rendering package may be used to get started. Unraveling the mystery. Your mission is to identify the characteristics of the data and ultimately unravel what they think or what you think they are. Can you use volume rendering to gain an overview of the data? Can you discover any patterns or trends? Does the data have any features? What do you think the data sets are? What phenomena do the data sets try to capture? Can you support your answers with visualizations that provide evidence? And then there's a list of hints, right? Sally is easier to identify than Betty. The data sets are not new, right? They've appeared in many papers already. They are both vector field data sets. That can introduce a little bit more complexity as well. That means there are three numbers at each data sample: an x component of the velocity, a y component of the velocity, and a z component. Some volume renderers can read in vector field data directly, but some can't. Volume rendering is usually about rendering scalar data. So if you want to derive a scalar field from the vector data, you need to use this formula, which is the distance, right? If the vector magnitude v of a vector is vx squared plus vy squared plus vz squared to the square root, all square rooted. That's the distance, right? That's a Pythagorean theorem. The tools websites have lots of helpful documentation on how to use them, right? There are lots of YouTube videos that describe how to use each tool and so on. And yeah, there are some more helpful hints there that I encourage you to read. And then that should say the fourth data set actually. The fourth data set is the Visible Human Project. Has anybody ever heard of the Visible Human Project before? Nice. How did you hear about it? Okay. Before I forget. So that's good. You learned something new today about the Visible Human Project. That is a male, an adult male and an adult female who donated their bodies to science after they passed away, obviously. And their bodies were sliced, they were sliced up from toe to head, right, in that direction, so to speak, the longitudinal direction of the cadaver, on the major axis. And the slices were very, very thin, like 1 millimeter each. So there was a camera, took a photo, first slice, took the next photo, next slice, next photo. And so we have a digital human called the Visible Human, a male and a female.
I saw something like that in a show. It was like the body show. I think where they had all these cadavers tried and put on display, and there was one that was all sliced.
Mm-hmm.
He had like class-wise as well?
I would say these are like the first two, like of all the digitized cadavers. Now, I mean, taking a photograph, taking a high-resolution photograph is like, I don't know. I guess it's not the most. Well, it's the most detailed way. You can only do that with a dead person, so to speak. Like the ultimate would be to have the high-resolution MRI image or something like that. Anyways, the last bit is to look at the visible human, to generate some images of the visible human. And again, just like in assignment 1, you follow a template format. So the template is described on page 3. You fill in the template for each image you supply. You supply 8 images, and you fill out a description of each 8 images. Right? The image itself, the tool you used, again, the type of visualization that you generated, the visual mappings again, and the unique observation. So it's almost exactly the same in some ways, but it's a different scenario. And then there's an example of a successful full points answer given there as well. And in this case, you can see somebody's brain, which is pretty exciting. Any questions about assignment 2? There's some more details there about how to submit and all that stuff. And yeah, but it's not very exciting.
But isn't the paper copies, they don't need to be colored, do they?
It would be good if you had color, yes. Yes,
It's very expensive.
it is more expensive. But I'm sure you have a friend with a color printer, or you know somebody. If you prepared ahead of time enough, or whatever that means, I can print it out of a color printer. But I'm sure that you can succeed with getting a color printout. Indigo?
Don't the CDT guys do exactly the same?
Which guys?
The CDT.
This. I guess the CDT guys, that's a good question. I guess if you have a data set that is relevant to your PhD and you'd like to substitute for...
Is that a volumetric data set?
Yeah, it would have to be some volumetric data set. Yeah. And some students might have a volumetric data set, some of them. Most of them will not, I think.
Yeah, I mean, I'm trying to find something.
But yes, a CDT student could use their own data sets. Those are PhD students, for anybody that's curious. Any other questions? Does that sound very exciting? It is exciting. It is very exciting. It's so funny to like experience the collective student body, because like the collective voice of the student of the class is like, I can't do this. I'm like, oh no. That's like the kind of the message I get, the collective message. But then when the pressure is on and you have to submit, suddenly, magically, you can do it. Like, magically, it happens. Like, you discover that you can do it, and then the scores are usually quite high, actually, the average scores for the class. But it's a paradox. So I sit there and I grade them, and the scores are really high. But the actual verbal message I get is, I can't do this.
It's not one university to people. It's in schools, no satisfaction.